welcome. I remain Prosper Ngongo, and in this week's topic, we're going to look at redox reaction. Remember our last topic, we talked about sulfur and its compound, and in regards to the chemical properties of some of this sulfur compound, we saw redox equations and was unable to explain fully because we do not have the base knowledge about redox equation. So this week we are going to be seeing a very important topic in chemistry, which is redox reaction, and so we're going to focus majorly on oxidizing and reducing agent. Let us dive into the objectives for this lesson. So the first objective for this lesson is you should be able to define oxidation and reduction, explain why they are complementary processes. Number two is you should be able to define oxidizing and reducing agent and describe how to test for them. And lastly, you should be able to relate the IUPAC naming to oxidation number. So we're going to just we're going to be fast about this, and so I want you to pay attention all too. So what are redox reactions? Now, redox reaction is a chemical reaction which oxidation states of atoms are changed. And there's some certain reactions that the oxidation state of compound do not change. In other words, the compound neither gains nor loses electron. So in redox reaction, a chemical species or an atom gains or loses electron. So that's what basically redox reaction is. So it involves transfer and the gain of electron, lose and gain of electron. So that's redox. The word redox is the joining of two words, reduction and oxidation. So let us see what is reduction and oxidation. How then do we define oxidation and reduction? Now there are three major ways we could define them. The first one is in regards to electron loss. We could define oxidation and reduction in regards to electron. The next we could define it in regards to oxygen loss or gain. And lastly, we could define in regards to hydrogen loss or gain. Let's begin. In regards to electron loss or gain, so oxidation is loss of electron, while reduction is gain of electron. Now, to enable you remember this very well, I'm going to give you a mnemonic, a memory aid, oil rig. Now repeat, oil rig. So what does oil rig mean? Now, in terms of oxidation and reduction, in regards to electron loss or gain, it is the major aspect of oxidation and reduction. Even in regards to oxygen, loss of oxygen, gain of oxygen, loss of hydrogen, gain of oxygen, in all of these, there is loss and gain of electrons. So the gain of electron or loss of electrons is the basis for oxidation and reduction. So what does oil rig mean? Oil rig means oxidation is loss, whereas reduction is gain. Oxidation is loss and reduction is gain. Let's consider the reaction we see here. We have a chemical species, let's say, assume it to be anything. Chemical species A reacting with chemical species B. Now what happens is A donates one of its electron to B. I repeat, A gives one of its electron to B. Now A becomes oxidized because A has lost an electron. So oxidation is lost. Now when the chemical species loses electron, just like A did, loses its electron to or transfers its electron to B, it is oxidized. And now when a chemical species gains an electron, it is reduced, as we see in the equation. Now to further express this, or let us bring in the chemical equation. Now zinc here has an oxidation state of 0, whereas copper in copper tetraoxosulfate 6 an oxidation state of +2. Now let's see what happens. Now since zinc is higher in the electrochemical series to copper, zinc is able to displace copper from tetraoxosulfate 6. Now copper has gained 2 electrons and become reduced to copper with an oxidation state of 0, where zinc has become oxidized with going from an oxidation state of 0 to oxidation state of +2. Now plus means it has lost 2 electrons and it has 2 protons more, so there is no balance in regards to oxygen. Now in regards to oxygen, oxidation is gain of oxygen, whereas reduction is loss of oxygen. Now it is an opposite, it's opposite of electron. In regards to electron, oxidation is loss of electron, whereas reduction is gain of electron. Now, in regards to oxygen, oxidation is gain of oxygen, whereas reduction is loss of oxygen. Let us consider a chemical equation. Here in this case, copper oxide is reduced because it loses oxygen and become copper metal, whereas magnesium gains the oxygen that was lost by copper to become magnesium oxide. Lastly, in regards to hydrogen, oxidation is loss of hydrogen, whereas reduction is gain of hydrogen. So this follows the oil rig, that is in regards to electron, oxidation is loss of hydrogen, whereas reduction is gain of hydrogen. So let's consider the reaction between ammonia and bromine. Now in this case, ammonia loses its hydrogen to bromine. Now ammonia loses it to become nitrogen. Now since ammonia has lost its hydrogen, it means it is oxidized, whereas bromine is reduced because it gains hydrogen. Let's proceed. So what are the common oxidizing and reducing agents, or how do we actually look at oxidizing and reducing agents? Since we've talked about oxidation and reduction, how do we see oxidizing and reducing agents? Now, a reducing agent is a substance that can be oxidized by losing some of its electron. Now, take a while and think about it. A reducing agent is a substance that can be oxidized by losing some of its electrons, whereas an oxidizing agent is a substance that can be reduced by obtaining electrons. Now let us look for the simplest one. You could go with any of these, but let's say oxidation state increases, act as an electron donor. Let us go with that. Let's go with number 3 and number 4. Acts as an electron donor. Now if you are a reducing agent,